biologist is researching a newly discovered species of bacteria. At time t equals 0 hours, he puts 100 bacteria into what he has determined to be a favorable growth medium. 6 hours later, he measures 450 bacteria. Assuming exponential growth, what is the growth constant K for the bacteria? For this exponential word problem, we will be using the growth to K formula, where A is the ending amount of whatever you're dealing with, and where P is the beginning amount of that same whatever. R is the growth or decay rate, and T is time. So, for this problem, the ending amount is A equals 450 and the beginning amount is 100, so P equals 100 and T equals 6. The only variable I don't have a value for is the growth constant K, which also happens to be what I'm looking for. So, I'll plug in all the known values and then solve for the growth constant. Here, we have the growth to K formula with the variables still intact. This is our growth to K formula with the variables being replaced with the known values. From here, we divide both sides by 100, so we cancel out the 100 on the right side, and the 450 from the left side becomes 4.5. Then, both sides by the natural logarithm to cancel out e. Then, divide both sides by 6 to isolate the variable k. After that, you will get the value 0.2506, which is the growth constant. Congratulations, you have successfully solved a word problem involving an exponential function. Remember the formula and take it step by step and you will get the answer. Now, let's tackle a word problem involving a logarithmic function. In acoustics, loudness is the subjective perception of sound pressure. More formally, it is defined as that attribute of auditory sensation in terms of which sounds can be ordered on a scale extending from quiet to loud. Loudness is measured in decibels. A cat's purr begins in its brain. A repetitive neural oscillator sends messages to the laryngeal muscles, causing them to twitch at a rate of 25 to 150 vibrations per second. For instance, a cat's purr is about 316 times as intense as the threshold sound. The formula for the loudness of a sound is given by where I is the decibels being emitted, where I sub O is the intensity of threshold sound, or sound that can barely be perceived. In this problem, our I is defined as 316. So that will be I equals 316 I sub O. Here, we have the formula for loudness with the variables still intact. This is our formula with the variables being replaced with the known values. From here, we cancel out the 2I sub 0 due to division, so all that's left is the 316. The next step is to evaluate all that's left. After that, you will get the value 24.996 and so on. Congratulations, you have successfully solved a word problem involving a logarithmic function. Remember the formula and take it step by step and you will get the answer.